binary erasure channel. By the way, we will generally write discrete memberless channels with the elements of Sx on the left, the elements of Sy on the right, and arrows indicating what transitions are possible. So here, in the binary erasure channel, Sx is binary. Sy is not binary. It contains the binary elements, but it also contains a special symbol E. And what we can have, representing this on a graph, there's Sx, there's Sy. If I get a 0, I can go to 0 or E, and if I get a 1, I can go to 1 or E. So I'm going to label these with the probabilities of each event occurring. So the probability of going from either letter to E, I'm going to call that PE. And so therefore the probability of going from 0 to 0 is what?
1 minus 2p over 2.
Okay, so
No.
so this is P of y given x. These are the y's and these are the x's. The summation has to be equal to 1 over y, but not x. So if I start with x equals 0, I know that there's only two possible ways I can go. I can go here with probability PE, or here with probability
1 minus p.
1 minus P.
This is the conditional again, as you said. You're writing on the arrows
Yes.
p, y given x.
Yes, that's right. So this is x, this is y, this is P of y given x. That's the label here. So, what does this mean? This means if so for example, if I have channel inputs 0, 1, 0, 1, 1, 0, I could get mapped to E, 1, 0, E, E, 0, or something like that. So in other words, if I observe something at the output, it's guaranteed that that's what was transmitted. But if I observe an E, I have no idea what was transmitted. This channel model has been used to model dropped packets on the internet. So if I observe a bit, I know for sure that that was transmitted error-free, but some of the packets might have been dropped. So in that case, I have no idea what might have been transmitted. Oops. So the mutual information we're going to express this as h of y minus h of y given x. Let's calculate these quantities. H of y given x, let's start with that. This is equal to the sum over x and y, probability preferable to express it this way. Sum over x, p of x, sum over y, p of y given x, log 1 over p y given x. So this is equal to, let's take the two cases of x equals 0 and 1. So I have p of 0 times the three possibilities over here are 0, 1, and e. So this is the probability of 0 given 0, log over p 0 given 0, plus log p 1 given 0. Whoops, excuse me. That's not log there. P1 given 0, log 1 over P1 given 0. This is y given x. Plus P e given 0, log 1 over P e given 0. Plus P of 1 times P of, excuse me, so this is x equals 1, probably 0 given 1, log 1 over P 0 given 1, plus P 1 given 1, log 1 over P 1 given 1, plus P e given 1, log 1 over P e given 1. So first off, we can drop two terms immediately. Probability of y equals 0 given x equals 1 is 0. This term is gone. Similarly, the probability that y equals 1 given x equals 0 is 0. So that term is gone. The probability of receiving a 0 given that a 0 was sent, what is that? 1 minus p. And the probability of receiving an e given that a 0 was sent is p. So this is p0, which is, excuse me, similar. So let me rate this. 1 minus pe log 1 over 1 minus pe, and this is pe log 1 over pe. Down here, probability 1 given 1 is also 1 minus pe, so this is 1 minus pe log 1 over 1 minus pe, plus probability e given 1 is pe, like so. So in fact, I have the same term under both brackets. It's 1 minus pe log 1 minus pe, 1 over 1 minus pe, plus pe log pe. Same thing appears here. So I can take that out. P0 plus P1 is equal to what? It's equal to 1. So therefore this is equal to 1 minus PE log 1 over 1 minus PE plus PE log 1 over PE. Okay, I'm going to define a special function here. H of P is equal to P log 1 over P plus 1 minus P